Today we're going to look at the installation of the SIPS panels, which stands for Structurally Insulated Panels, which we have on site today. As you can see, we have two of them installed on the building behind me right now, and we have a third getting ready, being moved along by the lull, which is a big sort of rolling crane, which will take these rather heavy and long panels and install them piece by piece like a jigsaw puzzle onto the building. Now, these panels are a very important and interesting part of our design and construction process, because with these panels we're taking all the CAD information, the computer drawing information you might say, and we're using that to create the building in the field very directly. Traditionally, the CAD program is used to draw plans, and those plans are taken to the site and interpreted and built. In this case, these panels were made directly from the CAD drawings that we had, or the computer drawings that we had, and they were pre-cut in a factory in Vermont and then shipped up here. So when they came on site, they're pre-configured to fit exactly on the building, accommodating the roof pitch, the window openings, the door openings, and any other details that we need them to. All of that was figured ahead of time, pre-configured before it came to the site. Now, the benefit of that is that when we develop these very detailed CAD models, we can get all the specific information correct in the model, check it for accuracy, and then from there go straight in production. We don't have another step where that needs to again be interpreted in the field and then reinterpreted and built. So there's not only the advantage of the accuracy of the drawings, but also there's the advantage of the speed of production and construction. And in construction, when we're trying to achieve a building for low construction costs, one of the ways we do it without sacrificing the integrity of the materials or the shell is to reduce the labor. And in reducing the labor, we use such components as these pre-configured panels. Now, as you can see behind me right now, they just slide together and lock in. And the other benefit of these panels, besides the production, is their thermal performance. It's a urethane foam which has both a high R value and also, importantly, moisture resistance. So this shell, we provide a continuous layer of thermal and moisture break around the entire shell of the building, which is good for the R value, but also is good for the infiltration and the moisture issues that we see in standard construction. The other advantage of this, what we're using here, are these very long panels. The size of the panels are 4 feet wide by 24 feet long. The advantage of using such large panels is that, as you can see, there's very few joints in the building shell. Traditionally, shell materials used to be lapped board siding or 4 by 8 sheets of plywood, but in our case we have 4 by 24 feet, resulting in just one simple joint, and then that joint can be very carefully connected to the adjacent panel and then sealed multiple times. We'll do it internally within the panel, and then also we'll add a layer of adhesive back membrane to the exterior, because again, we're always trying to limit the amount of infiltration or unwanted airflow into the building.